Alright guys, hi, this is geometry, our very first video. Today we're going to be talking about points, lines, and planes. Now the vocabulary in geometry is very important. You have to know what I'm talking about and how to identify each of the things as we go. So it might be a good idea in your notes to have a few pages where it's just the vocabulary, sort of a glossary if you will, maybe at the front or maybe at the back. You can include all the chapters as we go through in one little glossary, or maybe on a separate sheet of paper that you keep in a notebook. Your vocabulary terms, your postulates, and your theorems are going to be very important that you write them down, keep up with them, and be able to find them very quickly. The first thing you need to know are undefined terms. So there are basic figures in geometry that you can't define by using any other figures, while most of the figures that we do in geometry will be defined by these basic undefinable terms. The first one is a point. A point is going to name a location. Keep in mind that while the size of the point on the page is going to have size, a point in itself does not have a size. Okay, and it just responds to a location and is represented by a dot. When we name it, it's going to have the dot, and it will use a capital letter every single time. So like a capital A or a capital B. A line is going to be a straight path. It has no thickness whatsoever, and it's going to extend, continuing in that straight path forever. Now when you have a line, there are a couple of different ways you can name a line. So let's say that this is our line. We could name it by naming 2 points that are on that line, like A and B. We can name it by a script letter. So we could say that this is line L, or we could say that it is line AB, right? And a plane is going to be a flat surface that has no thickness and it extends forever. So think of a line as being the edge of a piece of paper and the plane being the top of the paper where you would write on it. So when we identify a plane, we can name it by a script letter also. So like this could be our plane, and maybe we've got points X, Y, and Z in our plane. We might also just say that it is plane R. It's going to be a script letter and it's going to be capitalized. So we could say that it is plane R, or we could say that it is plane X, Y, Z by naming 3 points that are found on the plane. Now, if you have points that all lie on the same line, we would say they are collinear. So remember, linear means line. So let's say we had this line and we had A, we had B, and we had C. We would say that they are collinear. If something can be collinear, that means it can also, the corollary is true as well. You can have something that is non-collinear. So let's say we had D down here. It is not on the line, so we would say it is non-collinear. You could also have planes, points on a plane that are coplanar. So if we have our plane and we have A, B, and C, those would be coplanar. They're on the same plane. But you might have D over here. That would be non-coplanar. So let's name some points, lines, and planes. Looking at this picture, I've indicated a few points and a few planes and a few lines on this really neat looking architecture of this building. So let's name 4 coplanar points. So as you look at each individual plane, you want to find 4 points that are all on the same plane. So if we were looking at A, B, C, and E, those are not coplanar because E is not on the same plane. D, E, and F are on the same plane, but there are only 3. So the only place where we are going to have 4 coplanar points is going to be on plane A, B, C, and D. And they would be point A, point B, point C, and point D. Now let's name 3 lines. There are several lines that are on this page. We can't name this line because we don't know its beginning. We only know its end. We can't name this line because we don't know the points that are on that one as well. We can't name this one because we only know 1 point on it. But we could name this one. So we could call this line CD, or we could call it line DC. We can also do this one right here. That would be line ED or line DE. Okay, we could do this line right here. That would be line DF or line FD. It does not matter what order you put the letters when you're talking about a line. The other line you could name is this one right here. There are 4 lines that we could name easily. That would be line EF or line FE. Let me just make a comment here that if I told you to name 3 lines and you said line CD, line DC, and line ED, I would only give you credit for doing 2 of them because this names the same line. Okay? That's like saying that you're naming the people in the room, and you could say, oh, that's Mrs. Williams, or that is Lisha Williams. That is the same person, so it only names one person. Segments and rays are another couple of lines that we will be using pretty regularly, figures in geometry, and we are going to define them using points and lines and planes. So a segment is going to be the piece of a line that has 2 points and all the points that lie in between them. So let's say we have this line here, and we've got some points on here. We've got A, B, C, and D. A line segment isn't going to be the whole line. It's only talking about part of the line between any 2 points. So we could say that we wanted to do line segment AC. That means everywhere from between A all the way to C and all the points in between it. So the difference between the way you would identify a line segment versus a line is your line has arrows on it, and when you name it, the little line above the letters has arrows on it, while a segment doesn't have arrows because it is just the end points. We just want A to C. We don't want the ones on the ends of them. So an end point is going to be the end of the segment, or the starting point of the segment, as well as the starting point of a ray. So an endpoint is very important. So a ray is kind of a combination between a segment and a line. So we could look at this and we could say a ray, we could look between C and continuing on. So a ray is always going to have an endpoint, like C, and we're going to need to use another endpoint. It needs to have 2 points. It's not an endpoint, it's just another point on the line to indicate what direction the line is going from. It starts at C and it moves off and continues past D. So the way we would write that is you have your little ray on top and it would be CD. Now it does matter in this one what order your letters go in. The endpoint letter has to be the first letter named because that tells me it starts at C and continues past D. So if I was wanting ray, this ray right here, I would say ray BA because it's going to start right here at B and continue past A. So it has to be that order. In a line segment and in a line, I could say line segment CA and it means the same thing, but a ray, it's a specific order. Now an opposite ray is going to be 2 rays that have a common endpoint and form a line. So looking back at our line up here, let's say we wanted C to be our endpoint. So 2 opposite rays that would be going here would be this one starting at C and then this one starting at C. So we could say that the common rays in this case would be ray CA and ray CD. They have a common endpoint of C. You can see that it's listed first in both of those namings, and then together they form a line. So let's draw some segments and rays. So we're going to draw and we're going to label. I want you to draw on your notes a segment that has endpoints U and V. So it can look a lot of different ways, but you need to have an endpoint and then a line and then an endpoint, okay? And then label it U and V, all right? If you put arrows on the end, that's wrong because that is a line, not a segment. Let's draw opposite rays with a common endpoint of Q. Now I've left out some information here, but it doesn't really matter. All that really matters is that we have our endpoint that is labeled Q and that our two rays go in opposite direction. But remember, a ray's got to have 2 points. So let's just name this one A and this one R. Doesn't even matter what letters we choose, as long as we have another point on there. All right, so one thing that you're going to get lots of practice with are postulates. So a postulate is a statement that we accept as being a true statement, but we don't prove that it is true. There are lots of things that we're going to prove. Theorems will prove that they're true. Postulates are used to prove that a statement is true, that a theorem is true. So the first postulate that you're going to want to write down in your notes, make sure you can find it very quickly and easily, is that through any 2 points, there is only one line that is going to connect them. You're not going to have more than one line. If we have a point here and we have a point here, there's only one line that is going to connect it. And then the next postulate is that if you have 3 non-collinear points, which means they might look like this, then there's exactly one plane that contains them. No more than one, only one. So if you have 3 non-collinear points, you have a plane that contains them. If you have 2 points, there's only one line that will contain them. Now, if you have 2 points that lie in a plane, then that line containing those points lies in the plane. So if we have our 2 points and we have a line that's connecting them, and they are lying in the plane, then the line is also in the plane. Okay. It's kind of like if you are in the kitchen, you are also in the house because the kitchen is in the house. Does that make sense? Now, if 2 lines intersect, then they intersect at exactly 1 point. So if we have this line here and we have this line here, they are going to intersect at 1 point exactly. And then the next one, if 2 planes intersect, then they intersect in 1 line. So I'm going to have to draw over my words here, but if we have this plane and we were going to intersect, we're going to take it and we're going to cut it in half with another plane, then where they would meet would be 1 line. Okay, I can imagine that the paper is going through the other one. So let's represent some intersections here. All right, so if a line intersects a plane but doesn't lie in the plane. Okay, so a line is crossing the plane but it doesn't lie in the plane. What do you think that might look like? So when we do this, we're going to have our plane. The way that you show that it's going through and it's not really the part you can see anymore is going to be a dotted line. So let's say we've got our plane here. Let's call this plane R. And we have a line that's coming through, but it's not lying on the plane, so it's not going to lie flat on there. We're going to say that it's going through like this. Okay, so then there's the bottom of the line. So where we can't see it is dotted, and where we can see it is going to be solid. Let's call that line L. So line L is crossing through that plane, but it's not lying in the plane. Let's say that we've got 2 planes that intersect on 1 line. Now here's where my drawing skills are really going to come into play. So let's say I've got a plane right here, and I want to intersect it with a plane that comes right here. So I'm going to make some adjustments to my lines here. Where these guys cross, let's say that this is dotted and this one's dotted. I can't really erase it. Where they cross would be a line. The picture is much better in your book if you want to look at example 4 on page 8. So when you come to class tomorrow, be able to look at a picture and identify coplanar points. Be able to identify lines that are on a picture, just like the architecture building. Be able to draw and label line segments and rays. And then be able to sketch 2 intersecting lines and a figure that shows a line that lies in a plane. All right, so be able to do all those things when you come to class, and I'll see you later. Have a good night.